Hello everyone, my name is Jyotirmoy. In this video, I am going to derive the transfer function from state space equation. So the basic difference between transfer function and state space equation is the transfer function involves the characterization of the system with the help of the output and input only, while in state space equation the characterization is done with the help of the output and input as well as the state of the system. So in order to derive the transfer function, we have to know the state equation. So I have written down the state equation here. The state equation says that x dot is equals to a times x of s plus b times u of s, which is known as the state equation, and the output equation is y is equals to c times x of s plus d times u of s. So this x dot is the differentiation of the state vector. So this is the state vector, and the a of a is known as the system matrix or the state matrix. B is the input matrix, and which is multiplied to u, which is the input vector, and y is the output vector, to which is equals to c into x, where c is the output matrix and x is the state vector, and d is known as the direct transmission matrix, and u is the input vector. So and all this x y and x dot are in time domain, and this a b c d are matrix, and it will have some value, and but in Laplace transform we have to take the equation into S domain. So how we can do that is by taking the Laplace transform. So if we take the Laplace transform of this first equation, we will have s times x of s minus x0 is equals to a times x of s plus b times u of s. So this x0 will be 0, because while deriving the transfer function we consider all the initial states to be 0. So this, if we take this a times x of s to the left hand side, we will have x of s minus a times x of s is equals to b times u of s. So if we take x of s to be common, then we will have x of s into si minus a is equals to b times u of s. So why si? Because this all are in matrix, and I is the identity matrix. This identity matrix will depend on the number of state vector will the equation will have. So if we take this si minus a inverse to the right hand side, we will have x of s is equals to b times u of s divided by si minus a. But we cannot write this in this form, because these all are a matrix and we cannot do division operation of matrix. So in the alternate of division of operation in matrix is taking inverse. So it will be x of s equals to si minus a inverse times b of u of s. So if we put this value of x of s to in the output equation, we will get the transfer function of the system which we are looking for. So taking the Laplace transform of this output equation, we will have y of s is equals to c times x of s plus d times u of s. So if we replace the value of x of s in the second equation, we will have y of s equals to c times si minus a inverse times b of u of s and d times u of s. So if we take u of s a common, then we will have y of s equals to c times si minus a inverse times b plus d bracket u of s. And if we take u of s to the left hand side, we will have y of s equals to y of s by u of s equals to c times si minus a inverse b times b. So this is the expression of transfer function if we derive it from the state equation. So I hope that you found this video very helpful. Thank you.